video, I'll finalize the steps for installing the NGA code in the ASU Sol cluster. In the first series of the video, I explain how to install the prerequisites, and then later the leap library. Then this time I need to install how to explain the how to install the NGA. So let's click this. Then this is an NGA repository maintained by the Dr. Kasbawi here at ASU. And according to his suggestion, as of August 2023, the NGA runs that runs on the Sol cluster needs to use this feature /pl-dns. Usually we use the develop branch, but as of the August 2023, he is recommending to use this one. Okay, but this is probably subject to change, so make sure to check with me or Dr. Kasbawi about the stabilized version of the NGA repository in the Sol cluster. So I'm selecting this. So first need to download it. So clone, then copy, then let's go to the maybe logout, and let's log into the Sol cluster. So then I need to download and compile the code. So let's go to the codes, and I don't have NGA, so I already copied this statement of the cloning, the git cloning the NGA. So this time I need to have this extra flag so that I can download the pl-dns branch. Okay. So it is downloading, and I do have this NGA, and double check whether I downloaded the right branch by typing git branch. I do have this pl-dns branch. Okay, I downloaded. So then what's next? So first go over the README file. This explains what is the NGA code and what are the prerequisites, most of which we already installed. Leap, FFDW, LAPACK, HyPre, Silo HDF5, and SGF and zlib. So there's instruction about how to compile the NGA on the Agave cluster, but we're not going to follow this one because we are on the Sol cluster. Depending on the cluster, the way you compile the code sometimes quite different. And Agave cluster, we use the Intel compiler, but which we don't use in the Sol cluster. So then compiling Agave, then do I have more information? No. Let's check the wiki then. Then scroll down. Yeah, wiki is right here. How do I do it in the Sol cluster? So prerequisites we already installed. Then I cloned it, but this time if you just use this statement, then you download the master branch. So you need to specify which branch you want to download. And now you load the compilers in MPI. So if you don't want to bother to type these two every time you use the NGA, you can include in the bash LC. Okay, what do you want to include? So what I'm talking about is this script codes NGA. So what I mean is you want to include copy and paste these 3 lines, maybe here like this in the bash LC file. W. Then if you log out and log in, then the GCC and OpenMPI will load every time you log in. But I don't want to do this because NGA is not the only code I'm using. So what I want to do is I don't want to load anything. Instead, every time I need to use NGA, I simply run this alias. Then I manually load these two things. So that's the third step. So for the Sol cluster, use the GCC and OpenMPI like this, and we can ignore all the other clusters examples. Then you need to configure makefile.in in a way similar to the lib. So you want to create this text file in the directory under nga /src. Let's go there. So go to codes, nga, there's src, and there's no makefile.in. So let's create this one using the v editor. Okay. Then what type of the makefile.in should I have? Click this link. There's an example for Sol cluster, which we can just copy and paste. So let's copy from here all the way to the bottom until you see this Agave with intercompiler. Copy and paste, but after pressing I, then so you see that the insert, Command V. So then, just like a lib, so you see that the sum of the library paths is actually for the Dr. Kasbaui's account, so which you need to change. There are 3, 4, 5, 6, 7, 8, 9. So instead of changing it 9 times manually, you press escape, colon, %s / you want to replace this expression by, which is his ASU write ID, by your ASU write ID. This JKIM520 is mine, then change it to yours, and /g, so that you want to change it throughout the entire file. Then, and there's one more thing to change. These libraries are fine. These are installed in the prerequisite. However, the lib does not exist here. So this is my home directory, but lib does not exist here. There is no lib. So I know that I installed. By the way, by having the exclamation symbol, you can escape, colon, exclamation, then you can use all the command line, the comments, ls in your home directory. Then there's a codes lib. I think this is where the lib is. So right. So escape. Then let's go to codes lib. You need to update to the right path. Okay. Then I save and quit. So I'll create this makefile.in. Hopefully this will work. Then what's next? This is an example of the makefile.in. Let's go back. Then I configure makefile.in. Then I compile. If you're just to use the NGA to run the simulation, just make OPT is fine. However, if you have to implement or a new model, or if you need to debug the code, this make debug is usually useful. Okay, but this time I'll be using make OPT. So simply type the make OPT and let's wait. There are a bunch of the warnings. You can most of which you can easily ignore. If there is an error, the compilation will stop. So this will take some time. For your information, make OPT will run faster. The simulation will run faster if you use the make OPT, because the compiler does a lot more optimization than the make debug. However, compilation, because of that, compilation will take much more time. However, make debug here will take much less time in compiling the code. However, simulation will run much more slowly. There's a pros and cons. So make OPT is useful so that you can run the simulation. Make debug is useful so that you can debug the code. Those are that's the one difference. I'm hoping that the compilation will be done pretty soon. The NJ has many modules, so it's not going to take a minute to compile the code. This is actually huge code, even though it's pretty well maintained. Again, warnings are fine. So we are in combustion and solver. Like I said in the prerequisites, even though this is a CFD code, I mean, this compilation, understanding everything in the compilation, maybe the meaning of this dash I and F3 line length none, and there's no point of the trying to understand everything here. There are some important things like the dash O3. This is the optimization level. O3 is probably the most aggressive optimization so that the code runs faster. But in the make debug, it uses the dash O0, the zero level of the debug, zero level of code optimization. If code is optimized, it runs faster. Not necessarily, but though. Then it's creating the module because I know that because it's trying to do something in the probably not. So I think it's almost done. So doing something about the multi-grid. Okay. After individual modules are all compiled, it wants to link to the main executable file, and you have to check whether the main executable file is created. If it's not created, your compilation is not successful. So now we are in multi-phase. Okay, I think we're almost done. I think I saw the executable file name. NG code contains other binary executable files, so probably the compiler is compiling those small size codes, but they're not going to take too much time. So I'm waiting so that I can double check whether compilation is all successful, meaning that whether the binary files are created. Okay, so I don't see any error message. So I'm in the SLC source code directories. Let's go up. So the binary files can be found in bin directory. So I do see a bunch of the files. They are all executable files. This arts is the NGA main executable file, and now I have all the other small utilities. And so then this, before I go end this video, so there's one more thing I need to do. I'm trying to set up the scripts codes NGA. So you need to set up the environment variable for NGA so that you can run some of the bin files. So go to the home directory, cd, and I want to update the alias files. So this is about what? Something about the NGA, not the alias. I want to update the scripts codes nga.sh. So here I want to have the I want to define this NGA environment variable so that I can this updating the path is important because you can run the NGA anywhere in the Sol cluster. So I want to home codes NGA, home codes NGA. Yes, okay, I have that. So this is all. So NGA is installed and it's ready to fire.